Well, thanks, Ed. It's a pleasure to be here and talk about, as you just said, compulsion or reward in cigarette addiction. So traditional accounts of addiction stress the reinforcing or rewarding effects of engaging the behavior. So that can be either positive reinforcement, such as the euphoria and rush of getting high with the drug, enjoying the taste or smell, which cigarette smokers enjoy from smoking. And then there's negative reinforcement, which is the relief of something unpleasant when engaging in the act. So smokers talk about relieving their craving, calming down when upset, and relieving other withdrawal symptoms. But is there something else besides reasons for smoking that are driving the behavior? And one clue to how to go about assessing this comes from some really old approaches to assessing reasons that people give for smoking. Michael Russell, who was a pioneer in the field, building on the work of Impaired, Horn, and other researchers that interviewed smokers, found that there were a lot of reasons that smokers would endorse to different degrees, such as I like to smoke because I enjoy the taste, it helps me think and concentrate, which we know nicotine alone, even apart from smoking, has alerting effects. Smoking to relieve the gnawing hunger or craving for a cigarette, handling a cigarette, calming down, enjoying the pleasure of drawing smoke into my lungs, all these things and more are listed, enhancing relaxation, like smoking after a meal. But in addition, the early questionnaires had items such as these. I light up a cigarette without realizing that I still have one burning in the ashtray. I find myself smoking without remembering lighting up. And so we refer to those as an automaticity scale. And one of our speakers, Dr. Stephen Tiffany, was really an early appreciator of the role of automaticity in smoking. When you've been in the field long enough, like Steve and I, then when you get these PDFs online, they look really kind of raggedy like this. So anyways. So in preparation for this talk, I looked back at a number of our clinical trials that we've conducted at the Duke Center for Smoking Cessation over the last 10 to 15 years, where we administered these questionnaires assessing reasons to smoke, and went back and correlated automatic smoking with quit smoking treatment outcome. So in this study, which recruited about 400 smokers, we were studying, it was one of our first studies of the effects of starting nicotine patch treatment 2 weeks before a target quit date. And the idea was to devalue smoking before the quit date, just as eating food when you're not hungry is not as rewarding as it would be if you are hungry. Smoking on a patch with nicotine already present in the system reduces a lot of the rewarding effects of smoking, and we thought it would help people quit, and it has been shown to help people quit to start nicotine patch before a quit date. So in this study, there were 4 subgroups of 100 or so smokers in each cell. Half the smokers were randomly assigned to getting a nicotine patch for 2 weeks before their quit date, and the other half received a placebo patch, so it was a double-blind, randomized controlled trial. And then half of each of those groups continued to smoking their usual brand of cigarette for the 2 weeks leading up to the quit date, whereas the other half we switched to a so-called low-tar nicotine cigarette. These are cigarettes that have very low nicotine yields when smoked by Federal Trade Commission machines. We now know that actually smokers can defeat the filtration and get more nicotine if they want to, if they try. And the tobacco actually has just as much nicotine as any other cigarette tobacco, but nonetheless, we were wanting to give people an option to reduce the nicotine intake from their cigarette while they were wearing a nicotine patch. After the quit date, all the groups, all subjects received the same treatment, which was a standard course of nicotine patch treatment for 10 weeks total. So when we looked at the baseline score on that automatic smoking subscale, we found it was a really strong predictor of abstinence, which was assessed at weeks 7 to 10 after the quit date, so 4 weeks of continuous abstinence at the end of treatment. And as you can see, people with high automaticity, and it was a 4-point scale, so 3 and 4 I just defined as high automaticity. It was a minority of smokers who endorsed it to that extent, but that doesn't mean that the smokers who had scores of 1 and 2 don't have a lot of automaticity to their smoking. I mean, smoking is a very stereotyped behavior with a lot of automatic components, even if people are not smoking without realizing they're smoking, which was an extreme case of an automatic behavior. But you can see they had very poor success rates if they scored highly on that scale, and it was an independent predictor of abstinence, better than all the other scales that I looked at, and even better than a widely used measure of nicotine dependence, the Fagerström test for nicotine dependence questionnaire, which is a 6-item, very widely used instrument. And as you can see that in general, the high FTND scoring people, the bars on the right, were lower than on the left, but the effect of the high automaticity, the red compared to the blue, was actually more dramatic, especially in the people who didn't score that highly on the Fagerström test. In fact, there was no abstinent person in the low FTND score, high automaticity subgroup, but there were only 4 subjects in that subgroup. So I went on, looked at other of our studies over the years, and went to another trial that we did that had about 600 people enrolled, and this was a study of adaptive smoking cessation treatment, whereby we would start people on a nicotine patch, and based on their early response in terms of how much they did or didn't reduce their smoking, we switched them, either left them on the patch or switched them to an alternative treatment with varenicline or bupropion, that is Chantix or Zyban. But in any case, in this study, I just lumped everybody together, and once again, the red bars, the people with the high automaticity, were much less successful in quitting smoking. Again, there were no successes out of 13. I just made an artificial reading so you could see that red bar on the left side. And then there was a third study, which I won't present, but I looked at our third big trial in the last 10 years and found the same pattern of results. So automaticity is a real sign of likelihood to relapse. But coming back to that first study, when we looked at actual rewarding effects as rated on a standardized questionnaire which we developed, which assessed things like satisfaction. This included items like enjoying smoking, liking the taste, and so forth, and then something we call a psychological reward scale that tapped items like calming down and modulating their arousal and attention, and so forth. And then there's craving reduction and enjoying the feeling of inhaling smoke into their throat and chest. This questionnaire, by the way, not only has been somewhat validated with factor analyses, but recently something called rash item analysis has shown it to perform very well in psychometric terms. So anyway, when we looked at those items, wearing a nicotine patch reduces the rewarding effects of smoking. And when we looked at the pre-quit reduction in rewarding effects over the 2 weeks, it didn't predict who went on to be successfully abstinent or not. There was no significant difference at all between the people who went on to be successful versus failures in terms of how much reduction in reward they experienced while on the nicotine patch and while smoking their own brand. In this case, this was people in the usual brand condition. So that was interesting because our initial approach was to think, well, if you devalue a cigarette, then people won't want to do it and it'll make it easier to quit. But it didn't really predict outcome. And that is a hallmark of automaticity, is when you change the value of something if people go on doing it. In contrast, the extent to which smokers reduce their actual smoking behavior in that first 2 weeks was a strong predictor of outcomes. So those who cut down on their cigarettes per day, their cigarette consumption in the 2 weeks, went on to have a much higher abstinent rate. So this shows that abstinent smokers had cut down more than the ones who had gone on to relapse. Interestingly, even though they were high on automaticity, those same smokers did have their smoking affected by wearing a nicotine patch compared to a placebo patch. So the red lines are the high automaticity smokers, and the solid red line shows them on a nicotine patch. So it didn't knock their smoking way down, but it did have a significant effect. So just because it's highly automatic doesn't mean it's not susceptible to pharmacologic influences, in particular by nicotine. A similar kind of a finding in a very different context was published by Eric Donny et al. In a study of low nicotine content cigarettes. So these cigarettes really do have lower and lower graded reductions in nicotine content, unlike the so-called low-tar nicotine cigarettes I alluded to before. And what Donny and colleagues did was allow smokers to remain on their usual brand or be assigned to lower and lower nicotine content cigarettes. And in the bottom panel is the actual measure of their nicotine in the system, measured by urine analysis of nicotine and its metabolites. The levels show a graded reduction. They should actually go down to near zero, so the fact that they don't means some people were cheating and having high nicotine cigarettes even though they were told to switch to the ultra low. But in general, there was a dramatic decrease in the nicotine levels in their system. But the top panel shows their total cigarette consumption was remarkably constant. So that's, again, a sign of a high degree of automaticity. And interestingly, their change in that FTND score of dependence hardly budged. It was statistically significant reduction in the very low nicotine cigarette groups, but hardly different. When you look at those bars, it was pretty similar, showing the importance of the behavioral component of addiction. So how do behaviors become that automatic? Well, let's start by looking how does a behavior happen in the first place. So movements are initiated directly by the strip of tissue in the motor cortex, just in front of the central sulcus of the brain. And you see there's something there called the homunculus, the distorted image of a human being, that shows not all body parts are created equal. So some muscles get more real estate in brain tissue than others, and in particular, the hand and the mouth get a lot of brain tissue allocated to them. And it's perhaps no coincidence that, indeed, hand and mouth are very important for smokers. But the motor cortex is sort of like the final actuator of voluntary muscle movements, but it really receives its command marching orders, so to speak, from other brain regions, in particular the frontal lobes of the brain, which in turn integrate information from the posterior sensory regions, and the frontal lobes being associated with executive capabilities, planning, and so forth, issue those commands. But then that whole system is strongly modulated by subcortical structures, in particular the cerebellum, which coordinates movements, and which I think, Frankenstein's monster had some cerebellar defect the way he walked, but also the striatum, and so there's the ventral striatum, and there's the dorsal striatum, which has the caudate and putamen. You also see here the globus pallidus, and all these regions are very important in affecting the initiation of movements, the force with which they're executed, and in chunking habits together, as we'll see. This is another view of the striatum. So the caudate curves around from the head to the tail, and you see the putamen as well. So those, again, are the dorsal striatum. At the bottom in red, the nucleus accumbens is a target for dopamine that is very important in drug reward, and pretty much all drugs of abuse release dopamine in the nucleus accumbens. But there are a lot of circuits that have been worked out, and the references to some of these papers here are things you can check into later if you want, in terms of the thalamus and the caudate, putamen, subthalamic nucleus, et cetera, coordinating movements. it turns out, and this is a very recent paper, July of this year, that nicotinic cholinergic receptors are also in the striatum, and they are important in modulating the activity of what are known as the medium spiny neurons in the striatum. Again, those who are interested can look at this paper, but as you can tell, they describe some complex interactions between these different striatal components. Anne Graybiel has really done a lot of instrumental work on how the striatum encodes habits that are not sensitive to changes in the reward value. So I would encourage you to check into her work as well. And then also Barry Everett and Trevor Robbins have done a lot of work applying some of those concepts to drug addiction. And the basic message is that with the overlearning of a habit, the initial learning, which relies heavily on the ventral striatum to sense the reward or punishment associated with an action, as the action gets more routinized and automatic, the transfer of control goes more and more to the dorsal striatum, the putamen and caudate. Lee Hogarth has also done this kind of study with cigarette smokers, which I'll come back to in a minute. But he talks about these two distinct learning processes: action outcome learning, where you know what you want and you plan an action to get it, and that's sensitive to devaluation. So if you're thinking of going to have a meal and then somehow you feel sick or you're satiated, then you're less likely to do so. But once something becomes an ingrained stimulus-response association, it pretty much unrolls in response to a stimulus regardless of your underlying motivation, insensitive to devaluation. But not all habits become compulsions. I mean, just think about driving a car. It's a very automatic behavior. Even if you have a stick shift, it's a very automatic behavior to drive a car, and you don't have to think about what you're doing. But we'd hardly say that driving a car is a compulsive behavior. So not all habits do become compulsions. In this sort of addiction spiral, and I can't use a laser pointer to show, but if you look at it, drug seeking starts off with novelty seeking, which we'll be hearing more about from Andrew Tapper, one of our speakers. But as habits get developed, then eventually it turns into a compulsive-driven addiction. And Barry Everett has also speculated about some of the important mechanisms that underlie that transition from habit to compulsion. And here's just a partial list, and I added a couple of my own ideas to stimulate discussion to this. But one important aspect is that the frontal lobes are sort of losing their control over the output of the motor cortex. And that can happen through a number of reasons. I mean, there are genetic factors, which I'll allude to in a minute, but also psychostimulant drugs like cocaine and possibly nicotine themselves tend to encourage stimulus response behaviors at the cost of more deliberate frontal lobe controlled behaviors. Stress, negative mood, withdrawal symptoms also tend to shift control to SR types of automatic behaviors. That's why it's kind of hard to think clearly in an emergency situation. I could have also added alcohol to that list. Alcohol is also notorious for impairing frontal lobe function. And a related concept Barry Everett talks about is that somehow these circuits connecting the striatum, the thalamus, and the motor cortex get rigid in a compulsion. And what that exactly means needs to be fully discovered, but it's, again, more than just a habit per se, which is a normal part of efficient functioning of any skill. And then I want to mention the importance of sensory feedback, including the condition reinforcing stimuli. So, in other words, no motor or behavior movements are performed in a vacuum. But let me start by just citing some work. George Uhl and colleagues has been really great contributors to the notion that there are genetic determinants of addiction vulnerability, but also in the propensity to succeed and in collaborative research, we've actually developed a quit success genotype score that was successful in prospectively predicting who could quit smoking and who couldn't. So again, is a highly complex set of cell adhesion molecules that are governed by genes that help to maintain synapses that encode memories and learning. There are also changes in gray and white matter associated with being a heavy male smoker, which I take it means a heavy smoking male, not a smoker that weighs more than average. And in this study, a larger white matter, which is axonal fiber tracts volume in the putamen, was associated with being a smoker. Dr. Joe McClernand, one of our speakers today, his group has found that impaired inhibitory control by a frontal brain region, the inferior frontal gyrus, was predictive of the ability of people to resist smoking in a laboratory situation on the right graph, but also in terms of quitting success, as shown on the left graph. Again, striatal gray matter volume in another one of their studies predicted smoking cessation treatment outcome. And yet, as I say, it's not just the behavior, it's that the behavior leads to stimuli, condition reinforcing feedback cues. When you do something, you feel feedback. And Steve Goldberg first showed that you could get very high rates of nicotine self-administration in squirrel monkeys. And at that time, it was very difficult to demonstrate that animals would self-administer nicotine if he used what was called a second-order schedule, where responses would trigger a brief visual cue, and then every several visual cues, the animal would get nicotine. But it was the stimulus feedback that was vital. And he said, I think it was very prescient, that if nicotine functions as a reinforcer to maintain tobacco smoking, it is likely its reinforcing actions are magnified by interactions with interoceptive and exteroceptive stimuli associated with smoking. And as an analogy, I was thinking, you know, if I just take my fingers and put them together repeatedly, you know, there's no particular enjoyment of doing that. But if I take bubble wrap and just as every time I put my fingers together, I get this discrete feedback, I could just go on doing that all day, except I only have 25 minutes to get through my talk, so I won't. But the motor homunculus does meet the sensory homunculus. So there's also in your sensory cortex a topographic layout of body regions where, again, the mouth and hands get disproportionate real estate. And those two are indirectly connected. And if you Google search connectivity of the insula, the insula, which is the internal cortex that lies beneath the superficial layers that processes internal sensations, and which is already been shown to predict difficulty quitting smoking. So, for example, Damasio and colleagues found that people with damage to their insula from stroke compared to people who had stroke damage to other parts of the brain had much less difficulty quitting smoking if there was a disruption in that internal sensory processing area. So he found 12 of 13, he looked at people who had quit smoking and those who didn't. Of the people who quit smoking, 12 out of 13 quitters who had the insula lesions did so with ease versus only 4 out of 19 who had lesions in other brain regions. That odds ratio is actually an adjusted odds ratio. If you put those numbers in, you don't get 136, but he covaried other nuisance covariates as well as extent of the lesion. So it was a very strong effect, which has been replicated in another study. Many years ago, we locally anesthetized smokers' airways. I enlisted the help of Don Tashkin at UCLA, a pulmonologist, and we found that if we numbed smokers' airways, starting with the mouth, throat, and then had them inhale a lidocaine mist, their craving for cigarettes went down before smoking, and then the ability of smoking to relieve craving was attenuated. Since then, we've done the same kind of thing with more selective manipulations, like nicotinic receptor antagonists, that block airway sensations. Vapors report that in addition to seeing clouds and enjoying the flavor, that the throat hit that you get with every inhalation of cigarette smoke or e-cigarette aerosol, over half of the people rated that sensation as important or very important to them. And indeed, if you look at whether the putamen, the dorsal striatum region that's been implicated so much in habits and even in smoking behavior, and then the insula, the sensory processing region, how does the functional connectivity between those compare? And there are differences between smokers and non-smokers. And again, Joe McClernand's group has shown that the connectivity between insula and the sensory and motor cortex regions predicted quit smoking outcome. So how do we translate this into treatment approaches? Well, very briefly, I'll touch upon some ideas. For first, disrupting the SR, stimulus response, connections that underlie a habit, which is difficult because it is such an ingrained autonomous kind of process. I'll mention brand switching before the quit date in a minute, and then some sort of cutting edge research going on to look at interfering with the memory trace that has been consolidated in the brain or trying to extinguish that memory trace. Mindfulness training, which is a way of trying to enhance frontal lobe control, and then a habit substitution approach. So briefly, when we go back to that first study that I mentioned of the pre-quit nicotine patch and looked not just at the usual brand condition that I was talking about before, but also looked at the group that was switched to the low-tar nicotine cigarettes, at the right, the people who had the brand switch, there was no relation between the habit scale and abstinence. So perhaps we had disrupted some of that SR conditioning by making them change their brands to a totally different cigarette where they had to relearn how to extract the nicotine from it that they wanted. In terms of memory, it's been shown that every time you remember something, it is then brought back into a more labile state in the brain and is susceptible to disruption before then being reconsolidated and put back in the filing drawer, so to speak. And that there may be ways of using drugs affecting the neurotransmitter glutamate and blocking, for example, NMDA receptors that could interfere with that reconsolidation. Barry Everett has this interesting short article, Wiping Drug Memories, the idea that you may be able to erase some of the memories. And there's a phenomenon he refers to called super extinction, extinction being presenting drug cues without the usual drug reward. And if you remind an addict with cues and then present masked extinction trials, some studies have shown a beneficial effect. In this one case with a heroin addict, it was apparently very successful. But in other situations, it hasn't been, so a lot needs to be learned about how to implement that. Another Duke colleague, James Davis, has found some promising results teaching people mindfulness, which is basically attending non-judgmentally to one's moment-to-moment actions and experience, and emphasizing that self-awareness, which would then hopefully disrupt the automaticity of an SR habit. And as I say, he's gotten some early promising results. The last strategy I want to mention is, well, why not substitute another compulsive behavior for the harmful one of smoking? Our director of NIDA, first Alan Leshner, I think, used the term, and Nora Volkov used it, that addiction hijacks the brain's reward system. Well, what about hijacking the hijacker by switching from cigarettes to something that's much less harmful, which research suggests that e-cigarettes are likely to be far less harmful than combustible cigarettes. They come in a variety of forms, but they all use a battery that heats a vehicle of propylene glycol and glycerol to release a mist with nicotine. And one of the big problems is that people will often go on smoking their own cigarettes along with e-cigarettes. And one approach that we've just done a pilot study of to look at the ability of devaluing cigarettes to help people switch. And unlike a situation where you're just trying to get someone to quit the behavior, where devaluation doesn't necessarily work that well because of the automaticity, but if they have a choice of another alternative behavior, there's reason to believe in that situation, devaluing cigarettes could facilitate the shift to the alternative behavior. So what we did was we have tested a simple strategy whereby we tell the smoker, try to switch over to an e-cigarette, but if you feel you have to smoke your own cigarette, you can do that, but just precede it with an e-cigarette. And the idea is they'll be satiated with the e-cigarette, both from the nicotine and the sensory effects. So when they do smoke their own cigarette, it won't be as rewarding. And not only that, but the cues that would normally trigger smoking are now tied to using the e-cigarette first. So in a pilot study with 6 smokers, which we submitted to present at the next SR&T meeting in San Francisco in February, we found that these 6 menthol-preferring brand of cigarette smokers, when given a non-menthol e-cigarette, which was not preferred, when you see the satisfaction ratings, basically the e-cigarette was not as satisfying as the usual brand when the usual brand was smoked after a deprivation period. But if the usual brand was smoked right after the e-cigarette, it was much less satisfying. And then over a 1-week period, we found that the actual desirability or satisfaction was reversed, that initially on day 1, they rated their own cigarette more satisfying, but it had actually reversed by the end of the week by this conditioning procedure. So we have a NIDA grant pending to test that in a larger group of smokers. So in conclusion, I think we can say that smoking and other addictive behaviors are maintained in part by their positive and negative reinforcing consequences, but in addition, this automaticity develops, which independently does predict outcome. There are complex interactions, as we've seen, between a number of brain regions, the dorsal striatum being particularly important, but also insula and other sensory processing regions are extremely important in the development of a compulsive habit. And genetic influences are also really important. About half of the outcome in quit smoking is heritable, so there are important genes that can give clues to new targets, in fact, for therapy. And some of the potential strategies for helping get through this SR barrier include enhancing frontal lobe function and trying to disrupt the memories of conditioned responses, or, as I said in the last part, substituting a less harmful, although compulsive addictive behavior, but less harmful one for cigarette smoking. So I thank you for your attention.
Well, thanks, Jed, for a great talk. And we do have a few minutes for some questions. Edie.
It was worth the trip from Los Angeles to come and hear that talk. It was just great. I am very interested in potential sex differences and the automaticity and how sex differences might play into your therapeutic approaches to addressing this automaticity or compulsion, given that, we know men and women differ a whole lot in how much they care about how much nicotine is in a cigarette and in the neuroanatomical distribution of the response to smoking a cigarette. Women being more of a dorsal striatum responders, men being more ventral striatal responders.
Well, that's a great question, Edie, and I don't know if you noticed, but the homunculus I showed was a male homunculus, but in any case, I did look, anticipating that question, which actually Frederic Bem whispered into my ear that was a good thing to look at, and it's just that I thought Al Collins was going to torture me with that question. But it's a great question, and I just did a preliminary analysis looking at sex differences in that automaticity factor on the questionnaire, and there was no difference. So, and there was no difference in terms of its interaction with the dependence FTND score in predicting abstinence. But that's just a very cursory look. But I think as you've shown, Edie, there are sex differences in the dopamine receptor density in male versus female smokers. I don't know if you want to elaborate on that, but you know, at some level, I would expect sex differences, but on that global level, I didn't see anything jumping out yet, but something to definitely explore further.
First, I'm going to torture you with, you set me up. I'm going to take it beyond sex differences, Jed. I'm going to crucify you and others who take a variable and break it into yeses and nos. Please take your data and take the individual variation in automaticity and the smoking behavior. There is a powerful statistical analysis that you can use there that would make perhaps not many people in this audience, because not many of them are geneticists, but would make the geneticists go, ooh. But I have a question.
Oh, just on that point, though, I couldn't agree more on that point. In fact, every time we do analyses, we do use the continuous range of a variable, but just for graphic depiction, it came out clearer to do the dichotomy, but you're absolutely right.
I have a question, and this is a question that comes from a retired scientist and longtime nicotine researcher who, when I went to the happy hunting ground of retirement, I replaced my compulsion to do nicotine research with golf. And as I'm standing here, I have this almost unquenchable, I am not pulling your leg. I want to do this.
Right.
And I am such a bad golfer that this last summer, I decided to bite the bullet and take lessons from a good golfer, a really good teaching pro. And one of the things he taught me that I think is relevant to your discussion and all of our discussions: how do you break a bad habit? A bad motor behavior, which in my old addled brain is stored in the cerebellum. How do you break it? And his comment, my golf teaching pro, was to develop a competing behavior and then cement that. So my question is my golf pro right? And can we extend that sort of philosophy to our demon of smoking?
I think so, and that's actually why my number 2 in my list of substituting e-cigarettes, or there's also heat-not-burn systems, something that's very similar enough to smoking that has a chance to hijack the same compulsivity, sensory motor chain of behaviors, that it then does allow conversion to something that's potentially far less harmful. So it's kind of a pragmatic solution, whereas some of the more, I won't say science fiction, but cutting edge approaches that talk about memory erasure might ultimately do the best thing, or finding perhaps a compulsive behavior that doesn't even involve consuming nicotine. I mean, maybe you could substitute bubble wrap pressing for some behavior. I mean, there are a lot of options one could look at. Or what's that? Yeah, or golf. We could all do the golf swing. Thank you.
Okay, so we've run out of time for right now, but I remind you, we have an extended discussion session later on. So now we'll proceed to our next speaker.